All right, I want to do a quick review of acids and bases from last week just to solidify the concepts. So remember, we've been working on this idea of solutions, and we need to be able to distinguish between the different types of solutions such as electrolyte, non-electrolyte, unsaturated, saturated, and supersaturated. And now we have these words strong acids and strong bases and weak bases. Today we're going to define acids and bases, define what does it mean to be strong and weak, and also look into calculating pH in the end. Now, to start off, acids and bases are both just special types of electrolytes. An acid is one where I have a compound that, when I put it in water, dissociates to produce hydrogen ions, or H plus. Acids are pretty easy to identify by formula or by name because they typically start with an H, and they typically have the word acid in their name, like hydrochloric acid starts with the formula HCl. Sulfuric acid, formula H2SO4. A base is a compound that produces hydroxide ions in solution or can accept protons. There's actually a couple different definitions. I'm going to kind of blend them together here. And for simplest cases, we typically will see an OH, a hydroxide, at the end of a chemical that can act as a base. So for example, sodium hydroxide, NaOH, or calcium hydroxide, CaOH. There are exceptions to this when we talk about bases, but for now we'll keep it simple. Now, this idea of strong versus weak deals with how much the electrolyte dissociates. When an electrolyte fully dissociates, meaning that it 100% breaks apart into ions, we say that it is a strong electrolyte. A strong acid or a strong base fully dissociates so that in solution, none of the molecules are still together. The H plus and the Cl minus in this picture, for example, are completely separated. So HCl, or hydrochloric acid, is a strong acid. And just like with other electrolytes, we'll see that it conducts electricity. We'll see the light bulb on brightly. And the more of the acid I put in there, the brighter this light bulb will get, as it is able to conduct fully the power from the supply. Um, Contrast to that, we have weak acids and weak bases, and this term weak describes a compound that only partially dissociates. A weak acid or a weak base will stay together for the most part in water, or rather the molecules will stay together, but a few of them will dissociate. So in the picture here we have hydrofluoric acid, and we see the HF is still bonded in the case of most of these molecules, but every now and then you do get them separated by a little bit. And because of that small separation, they still conduct electricity, just weakly. So the light turns on, not quite as bright. And that's really the difference between strong versus weak.